All right. So it's hard to follow Jim. Thank you, Jim. I'll try to make this interesting. So what I'll be talking about is a journey that one of the applications within Bottomline has taken. It's, and I call it a journey because it's a never-ending quest to keep your application, to keep the quality high, and to meet the ever-changing demand of the business and of our technology, and of our competitors as well. All right. Okay, there we go. I think I have to keep my finger on the laptop. So who am I? So my name is John Soul. I work in the Enterprise Architecture group within Bottomline. Now this group is a shared services group. It's tasked with looking at technology across the entire company. So we'll look at how to introduce new technologies, how to consolidate technologies, what opinions we have on new factors within technology. So Docker is an example, cloud is an example. These are our new technologies to Bottomline that we help, instead of everyone figuring it out on their own, we help the company figure out how to use these technologies. We also look at processes as well. It's not just technology. It's, for example, how does an architecture support an agile process? Because the way you do things and the architecture work hand in hand. And we also look at standards across the enterprise. So we can look at things like security standards, how you should, what kind of Java libraries you should use for security, that type of WASP, so that type of thing. And in addition to the enterprise responsibilities, we also support lines of business. So PayModeX is the business, or PayModeX Business Solutions is a line of business that I support, and that is the logo right smack in the middle of the actual banner. So just to speed along the talk, so what I'll be talking about is modernizing a legacy, I won't say legacy, an established paymode application. And this probably is familiar to many of you. Is everyone familiar with this kind of architecture? It's a standard JEE architecture. It's probably been around for 10 years. It's very familiar to a lot of people because it works. It probably generated billions or even trillions of dollars of revenue. And it's easy to understand, it's easy to scale, there's a lot of tooling support for it. People, there's a lot of resources with their available available skill sets within the company and within the market itself. So it's a solid architecture. Okay, I'll just hold it. So that's pretty solid. So like I said, it worked for the longest time. And just to kind of quickly go over it, it's a standard Java application server. It's composed of the servlets and JSPs, EJBs at one time, but then they got replaced with POJOs, JPA entities. And it's deployed as a WAR, and it's scaled using the JEE app server and their clustering mechanism. It ties into an RDBMS for persistence, for OLAP and OLTP. It's separated out so you can handle those different transaction types. And there's a whole management and monitoring infrastructure for it, which helps you operate the entire set, just to make sure that it can scale out, and then you can perform upgrades and stuff. So what are the challenges for this kind of architecture? One, it's a very large code base. So if you think about trying to understand hundreds and thousands or maybe even millions of lines of code, and as Jim said, it's almost impossible for a single person to do that without the support of their entire team. And oftentimes you won't have anybody who really understands the actual whole code base. So one person who understands the whole code base decides to leave the company, then that's a tremendous risk. That's a position which a company should not be in. Also, with a single large code base, this makes the impact of a change fairly dramatic. So you can have a single line of code which introduces a bug within, say, a logging piece of the application, which can potentially bring down the entire application. Also, with this kind of architecture, you tend to... All right. That's good. Very agile. So with these single monolithic apps, you tend to have large releases, large quarterly, biannual, or yearly releases. And what this causes is that it causes a high testing effort. It's very expensive to test. So even though you might only change 10% of the whole code base, you got to regression test the entire application. It also causes all the functionality to share a common lifecycle. So maybe, again, you're only changing one or two pieces of the application. Those have to wait until the rest of the applications are actually developed, and then you release it. So it's not a, again, instead of, I don't want to overload the term agile, but it's not an agile way to get your products out to your customers. Operationally, it's very straightforward to actually monitor and manage these legacy applications. You have an application server. You can use the application server's tooling to actually monitor and manage it. But you lose that level of granularity. So if you want to try to focus on a single specific, very important piece of the legacy of the monolith, then it's very hard to do. So Apple, just my opinion, Apple's quality has gone down a little bit. And then the C connector is just a nightmare. I'll do it the manual way. Okay. So again, the big problem is this one big monolithic deployment artifact. So that makes the unit of scaling fairly coarse-grained. The traditional way to scale the monolith is to just replicate the monolith. And so you treat everything as the same. Your SLAs for everything is basically the same SLA. Even though some pieces of it might be not as important as other pieces, you have to treat everything the same. And then, of course, it's, everything I just talked about is not very agile. It's not very a good way to get features out to your customers. So what are the options to kind of address some of these challenges? There's probably a lot of options, but the ones that we focused on were these three. One of them was to just take that monolithic code and then just restructure it so that it's easier to make changes. So if you can do that, then you provide high cohesion, low coupling. You follow solid principles, and you have a rock solid application architecture. Then it makes changes a little bit easier, and it takes the risk out of making changes. Also, I think you saw it. We could have re-architected into using microservices, and then the other one was a hybrid approach. There we go. So these are some of the things that we're thinking about when we're talking about making these architectural decisions, because you don't make architectural decisions in a vacuum. We got team organizational considerations. Okay. Okay, why don't we do that? Yeah, that's getting distracting. 1 minute? Yeah, so take a picture of that, and then this one. Then hopefully. So again, so we don't do things in a vacuum. everything kind of impacts everything else within a development organization. So you have to take into account how the organization is structured. Has anyone heard of Conway's Law? Is that something you've heard about? So Conway's Law is something that Mr. Conway came up with a long time ago, and he basically said that the architecture of the product that you produce is a direct reflection of the organization's communication, lines of communication, and it's true. So if you, okay.
We have too many devices. We're switching from this laptop to this laptop, and it should work in a minute.
All right, so we talked about the organizational structure. You got to make sure that we can operate it. Hey, there we go.
Yay.
All right, awesome. Okay, so all my notes are on this. So. All right, so so things that we would consider is the structure of the teams, the operational readiness. So how is our hosting group familiar with managing and monitoring these applications? How are the client services familiar with fielding customer calls and then being able to alert the management teams and monitoring and management teams on what's going on? What skill sets does the team have? This could be in terms of application development. It could be languages that the teams are familiar with. And what's the SDLC processes? So as Jim said, Bottomline for 5 years, Bottomline has been going through this agile journey. And that has to align with the way the actual applications are architected, the way the actual applications are developed. So we'll look at the first option here. So the first option looks pretty much the same as the legacy option. I mean, the only thing we're changing is the quality of the implementation within the actual application. So there are benefits for doing that. Again, if you structure your code better, and this is, these are major projects that people undertook, decades ago, which is just simply restructuring code so that it's easier to understand and you can minimize the impact of change. So you can get those benefits. You can get better encapsulation, better coupling, or looser coupling. You can get a higher quality application, which minimizes the impact of a change, which minimizes the risk of making a change. But you still have the single monolith, so you're not addressing the real problem here when you're doing that. But if you do it this way, wrong one. What you do is it's faster to implement. It's something which everyone's already familiar with. And because it's faster to implement and because it's familiar, there's less short-term risk. But again, it doesn't address most of the challenges of the actual monolith. So the other option is a microservices architecture, which is probably something which all of you are familiar with, or at least heard about. So in the microservices architecture, you break out the monolith into their bound-in contexts. So each of the microservices are responsible for a specific business capability. You get the option of choosing the appropriate technology for each of the microservices. So one could be JEE, one could be a Node app, the other could be a Go. So you choose the technology which best supports the capabilities that are needed for that microservice. And then just taking lessons learned from Netflix. So you also have edge services. So you'll have a proxy which controls access into your microservices. You can have dynamic discovery into the proxy, so so the proxy doesn't start routing requests to services which aren't available. And then also you can have is there an electric pointer? An API gateway, which can serve different APIs to each of the different devices. So they'll have a better experience actually interacting with your microservices. And then you have to create a whole set of management monitoring infrastructure around it, because if you just deploy this without being able to operate it, then it's not going to be a very pretty picture. So what are the pros for microservices? You got a lot more scaling options. You can scale each of your microservices individually. You get more agility, so the organization itself can treat the life cycle of each of the microservices differently. You can release them differently. You can support A/B testing. You can support the ability to experiment and fail fast. And then you can monitor each of those individually. So because you can monitor them individually, you can understand the behavior of each microservice individually. And then you'll be able to scale out or scale down based on what their needs are. So the drawbacks for such an approach, it's high risk. This is something completely new to the organization. There isn't a whole lot of learning or experience with this kind of architecture. And it's a very complex architecture because it's a very distributed system. Organization itself is because it's a brand new architecture, it's not ready. It's not ready to develop, it's not ready to support or operate it. And because of these two factors, it takes a very long time to implement. So the business risk and the return that the business will have on the investment could be a very long time. So the choice that we took with Paymode was more of a hybrid architecture. So this is what I would call a pragmatic services approach. So this, and all of these haven't been built out yet. This is still being built out, and GlobalLogic has taken a large role in implementing this. So this is still using the technologies that we're familiar with, which is using JEE, using deploying in wars, and then having the same management and monitoring infrastructure, which people understand. Still taking advantage of the relational databases. But what we're doing is we're breaking it out, each of the individual functions, into its own, I'll call it microservice or domain service. The only thing which is lacking is that each of these services don't own their own data. They have a common view of the actual database, the data. So that is a drawback to this approach, but with it, you can still deliver pieces of the actual application, which can then be scaled independently, which can then have a different life cycle, and then which can also deliver different API experience to each of the clients. So the pros for this was it was practical. It reused most of the team skill sets. It wasn't just such a dramatic change. And because of this, it reduced less risk, and it was faster to implement. And the con, of course, is that shared database. So being able to break out that database into individual data sources for each of the microservices is an extremely hard undertaking. We'll have to change the data model, and then there's already terabytes of data within the actual application. So the cost for changing the model and then migrating the data over to the new model might not be worth the actual investment. And also with having a shared database, you're going to have multiple versions of these services. So how are you going to handle the actual multiple versions of the services when they all see the same data? That's something that's a large challenge, and that's something we'll have to tackle. So I mentioned a note about the hybrid and microservices being a complex architecture. It's a distributed architecture, which is extremely complex. It's very hard to understand. It's very hard to operate. You can have, in any complex system, you're going to have chains of microservices. So we need to be able to focus on the resiliency of the actual microservice. You don't want a failure in, say, a logging microservice causing other microservices, which are actually calling it, to start failing in themselves because threads are being blocked. So we have to implement patterns to make sure that our services are resilient. So we can implement bulkheads to make sure that the microservices are isolated from each other. You can have client-side circuit breakers so that in case one service is down, your client does not sit there and block, use up all its threads waiting for a response back. You can look at doing active-active support of the microservices. If they're stateless and they support it, then that'll provide you with a higher availability. We can also take advantage of what cloud offers. So if there are cloud resiliency capabilities, like within AWS, you have regions and then you have availability zones within regions. You can take advantage of that as well. Now, one of the hardest things about microservices is that you really have to reevaluate your consistency model. Within a monolith, you could have a transaction span multiple actual calls, but within microservices, that's just not going to work. You can't have it doesn't make sense to have distributed transactions within microservices. It just, it'll destroy most of the value of having a microservice. So because of that, you have to really reevaluate your consistency model, maybe, or even think about ways outside of the actual technology. For example, you can institute manual operations, or you can institute procedures which will help you on the back end bring everything back into consistency. So with architecture, especially with a dynamic architecture, you're always going to have a new target architecture. You're always going to keep looking forward because that's the way you drive the evolution of your application. So the target architecture, some of the technology changes which might drive a new target architecture are the desire for using cloud. For Docker and containerization, how would Docker images, how would deploying them on Kubernetes, how would that actually affect the architecture? The advent of reactive, so you have a focus on reactive streams. You got a group which formulates the Reactive Manifesto, and all of these came about because there's a need for a new type of architecture to provide a more responsive, more scalable user experience. And then also, as sort of as part of reactive, but it doesn't have to be reactive, microservices are more adopting an event-driven approach because there's a recognition that business really is more of an event-driven business, not really the way we model as a synchronous blocking interaction. And then you also have organizational changes. So Agile, of course, is one. How does CI/CD actually impact the architecture? Because again, you don't do architecture in a vacuum, so you want your architecture to be able to live synergistically with everything else within the organization. And DevOps, that's up there to help build out our CI/CD. And also, there's a bigger focus on handling failures, because again, the complexity of the architecture is just getting larger and larger. So the impact of a failure is going to get larger and larger, and we have to be able to handle that. So out of all these, I'm going to talk a little bit about reactive. So reactive, and are you familiar with reactive? Have you read the Reactive Manifesto? Okay, good. Yeah, so the Reactive Manifesto, it's a great read. It's go to reactivemanifesto.org, and it'll give you a good overview of reactive. So some of the tenets of a reactive system, and this is reactive systems, which is different than reactive programming. So some of the tenets are that it should be asynchronous and non-blocking interactions between components. Components should communicate via messaging. there should be back pressure to actually communicate the capacity of each of the components that are interacting, so that one component which might be slower than another component doesn't get overwhelmed. And the system should be resilient, so they should be able to recover themselves and ideally be self-healing. And all this together provides what's called a responsive user experience. So the user is not going to be sitting there blocking, waiting for a response back. They're always going to get a response. So it sounds great. So how would that look within our target architecture? So reactive, almost by its very definition, it dictates an event-driven kind of architecture. So with event-driven architectures, one of the things that is popular is a CQRS pattern. So you could have events coming in, being stored into an event log, and then you got a event-driven microservice which updates its state based on the actual events. And if there's a failure, it can replay the events based on the point where it captured the last event. And then on the query side, because events aren't very conducive to providing a good query response. So on the query side, you can have a service which takes the information and then creates a data structure so that people can actually query it. So that's I mean, CQRS is one. It could be one impact of developing a reactive architecture. And then you could have CQRS across all the different domain services. So again, we've complicated this even further now. So before, we've had basically one account microservice which was responsible for reads and writes. Now we've separated that into two components, which is responsible for reads and writes. So it's gotten much more complex, and then we have to put in the management and monitoring and all the operational stuff to make sure that we can operate this properly. So this is something, this is aspirational. This is something which might happen in the future. This might be something which, you might be working on if you're with GlobalLogic. It might be something you might be working on for pay mode. So we don't know. But that all depends on what the business needs are. And that, of course, the business always drives what's going to happen in the architecture. Okay, that's the end of my talk.